graph your triangle, and I'm pretty sure everybody kind of understands how to graph your triangle. Plot the 3 points and then click graph triangle button, and then it's going to graph it for you. But the problem here is that they are actually giving you the graph, but they're not giving you the ability to like write on it. And so if you notice here, we have a right triangle. So in class we learned to find the missing sides, and so what you're going to really have to do, guys, is kind of draw 3 separate triangles on the paper. So a triangle connecting I and H, a right triangle connecting H and J, and so forth, right? So I'm going to start off with connecting G and H. And so I know that this is going to be a right triangle that is going to connect G and H. So here I'm going to draw a little right triangle. All right, and this is going to be my G point, this is my H. But how many units are between H and J? So I'm going to come here and say 1, 2, 3, 4, 5. Let me make sure I count that again. 1, 2, 3, 4, 5. So we have 5 units on the height, and then the base would have 1, 2, 3, 4, 5, 6. So it would have a base of 6. And so here I'm actually able to figure out what is GI. Now I can plug in a squared plus b squared is equal to c squared, and I can solve. So 5 squared plus 6 squared is equal to c squared. And so here I'm able to actually start evaluating. So now I know 5 squared is equal to 25, 6 squared is equal to 36, and that's c squared. 36 plus 25 is 61, and that's equal to c squared. And so now I'm going to go ahead and take the square root of this, of both sides. So when I take the square root of both sides, I find that GH is actually going to have, well, if you leave it in the square root, it would be square root of 61. So C is approximately at square root of 61. Now I'm going to look at my additional triangles. Again, I'm going to do the same process. Okay, I see that I can construct a right triangle between I and H. So straight here, ending here. Kind of have to use your imagination a little bit, but then switch it up on your screen. So I'm going to construct a right triangle from I to H. Okay, so we have I and H, and I actually am going to draw it in the way they're kind of drawing it, just so it makes it easier for me to imagine. But I have 1, 2, 3, 4, 5. It has a base of 5, and it has a height of 1, 2. So I know it has a height of 2. So again, I'm going to plug this into Pythagorean theorem. 2 squared plus 5 squared is equal to c squared. That's 25 plus 4, which is equal to c squared. And then I have 25, that's going to give me 29. It's equal to c squared. So square root both sides, and c is equal to square root of 29. All right, so currently I have the side of GH. I have the side of IH. These two are not the same, and what I'm going to do is construct one more triangle, right? And I'm going to find the distance of IG now. And so again, I look at this side, IG, right? That's what I'm looking for. Kind of have a triangle that's going to be more this up and down shape, right? So I have G and I I'm looking for, and I know the base is, so again, if I'm trying to trace from I to J going straight down, I would have a height of 1, and then I am going to have a base of, let's go ahead and count that as well. All right, so I'm sorry, I thought something. Okay, so I'm going to also calculate the base, and the base is having a 7. Okay, so let's go down and count that as well. All right, so we'll have a 7 right there. So when I tell my Pythagorean theorem, I'm going to plug this, so I get 1 squared plus 7 squared is equal to c squared. That's going to give me 49 plus 1, which is equal to c squared. That gives me 50. So square root both sides. Once I square root both sides, I find that c is equal to square root of 50. So if you look at all of the sides, right, this side right here, our first side that we actually found, that was showing me the GH, right? And so I knew that GH was going to have a height of 61. And then I knew that IH is going to have a height of square root of 29. IG, the side IG, has a length of square root of 50, right? And so none of these are equal, and therefore I would be able to say that this triangle is indeed scalene. So I'm going to come to my mouse, I'm going to scroll down, and I can say I can prove the triangle is scalene by demonstrating that all three sides are of unequal measure. So I'm going to come here and I'm going to type in the side lengths. I have C, which is GH, I learned was the square root of 61. Again, you can actually type in SQRT and it auto does square root. HI is square root of 29, and IG is square root of 50. Now, before you enter your square roots, please make sure that they're in simplest form, guys. And in this case, this one is not in simplest form, so what I'm going to do is make sure that it is. Okay, so square root of 50, two things that multiply up to square root of 50 is, so again, I can rewrite square root of 50 as 25 times 2, right? And so think about what is the square root of 25? Well, the square root of 25 is 5. So I can rewrite this as square root of 25 times square root of 2. Now, I know square root of 2 is going to simplify down to just square root of 2, but square root of 5 actually simplifies down to 5. So we can rewrite square root of 50 as 5 square root 2. But other than that, you're good to go, and you can say all three side lengths are unequal, therefore this triangle is indeed scalene. Alright guys, so that is how you do problems like this. Again, if it is an additional problem, I would just kind of draw those triangles off to the side, because it is harder to sketch it on the screen because it doesn't allow you. So please make sure that you are kind of sketching toward the side.